Today, integration by parts, made easy. Here's the first of 4 problems that I'm going to do today. If you work through the whole video, you'll be prepared for pretty much anything that you're going to get in an integration by parts question in an exam or test. The first thing to do is not be scared by integration by parts. It's a direct consequence of the product rule in differentiation. And if you want to see how that works, I'll put that up right at the end. But all we need to do at this stage is focus on the question that we have in front of us. Now, integration by parts involves taking this integral, which is difficult, and basically turning it into an easier integral. And you need to be a little bit like a chess player here and think a few moves ahead. So here we have the integrand, what we're going to integrate, which is x times sine x. So what you want to think is, what happens if I integrate one part of the integrand and take the derivative of the other? So let's say, for example, I took the integral of x, I'd get x squared on 2, and I take the derivative of sine x, well then I'd get cos x. When I multiply those two, I get x squared cos x on 2. Well, that's no easier to integrate than what I've got before, well, what I've got now. So maybe I need to think about doing this the other way. The derivative of x is 1, and the integral of sine x is negative cos x. If I multiply 1 by negative cos x, I get negative cos x, which is very easy to integrate. So that's the way I probably want to go. So to do the solution, I always set things out exactly the same. That minimizes the risk of error in any exam or test that I'm going to do. So I write out u equals x because I want to take the derivative of x, remember, we just talked about that. And then on the right here I put u dash, which is the derivative of u, is equal to 1. Then I write down v dash equals sine x, which then means that when I write down v here, I'm writing down the integral of sine x, which is negative cos x. And now we're ready to write down the solution. So we put I equals, the first thing we need to do is write down the product of u and v, which is negative x cos x. Then we always write a negative sign before we do the integral. And the integral is the product of the two things that we've produced here on the right hand side of the page, the u dash and the v. So that's 1 times negative cos x dx. And as we said before, that'll give us an integral of cos x, which is very easy to work out. And so we get the last line that I equals negative x cos x plus sine x. And then of course we add this c, the constant, and that will give us full marks. So here's our second problem, and it illustrates one of the little tricks with integration by parts, and that is sometimes you need to integrate by parts twice. So if we think like a chess player, a few moves ahead here, we say if we take the derivative of x squared, we'll get 2x. Take the derivative of, the integral of sine x, we'll get plus or minus cos x, doesn't matter. And that's very similar, that integral then, 2x cos x is going to be very similar to what we saw in the first problem. And if we then integrate that again, well, the 2x is just going to go to 2, and the cos x will go to sine x, and we'll be left with a very easy integral. So let's see how this works. So we said that we'd take u equals x squared, which means that the derivative of u dash, is equal to 2x. We'll let the derivative of v with respect to x equals sine x, which means that v equals negative cos x. So that gives us I, the integral that we're asked to evaluate. This bit here is u times v, and this bit in the integral is u dash times v. And don't forget the negative before the integral. So we clean that up a little bit, and that's what we get. And now we look at this integral of 2x cos x dx, and we say, that's a classic for integration by parts. So we're going to integrate by parts the second time. So here we let u equal 2x, and we take the derivative of that, we get u dash equals 2. That means that the other part of the integrand, cos x, will label that as v dash, the derivative of v, which means that v equals sine of x over here. So now we can finish off the problem. We say that I equals, we've got this negative x squared cos x, which is what we had up here. And now these two parts are just the integral. This part here is the uv, and this is minus the integral of u dash v with respect to x. And that's an easy integral to work out. And so now we can finish it off by saying that I equals negative x squared cos x plus 2x sine x plus 2 cos x. And don't forget the constant, and then you get full marks. So if you've done a few integration by parts problems, you'll be ready for this little trick. So thinking like a chess player a few moves ahead, I think, well, I could take the integral of e to the x, I'll get e to the x. Differential of sine x is cos x, okay. What happens if I do it again? Well, I'll get e to the x times sine x. And that's the original problem. That's what I is, e to the x sine x. So maybe there's something that works there for us. So let's do the integration by parts twice and see what happens. So as I said, I'm going to let v dash equal e to the x and u equals sine x, and here are the calculations, and I get this expression for I. Now I have to do the integration of e to the x cos x, and you can see here the calculations for u and v dash and u dash and v, and so that gives me this expression for I. And the flash of inspiration is to realize that this integral that we now have is in fact I itself. So we can replace the integral with negative I, and that enables us then to put all the i's to one side. So we get this expression for 2i, and if we know what 2i is, then obviously we can work out what I is. Add the constant c, and we get full marks. And so to the last problem, which illustrates a trick that you should be aware of if you want to do well at integration by parts. This works for log x, which I've got here, but also things like the inverse sine, inverse cos, and inverse tan of x. So here we have a problem that doesn't look as though it's suited to integration by parts, because there's only one term, log x. So the trick is to introduce a second term, 1. So of course we can squeeze a 1 in here. 1 times log x is certainly log x. Now we think a few moves ahead. If we integrate the 1, we get x. If we take the derivative of log x, we get 1 on x. And if we multiply then the x times the 1x, we're going to get 1, which is very easy to integrate. So here's how the calculations look. I've put here u equals log x, and so u dash equals 1 on x. We said that we'd introduce this term 1 in, which means that v dash equals 1, and so v equals x. And so to calculate I, remember we take u times v, which is x log x, put the negative sign, and then the integral of the two things that we've produced, the u dash and the v. So that's 1 on x times x. So it only remains now to integrate 1 with respect to x, which is pretty easy. Add the constant c, and we get full marks. That's it for integration by parts made easy. I hope you found it useful.